So now that I have a good idea of what the steps are that I'm going to take in order to solve a problem, the steps that are going to be required for my program, the next thing that I need to do is decide on the variables. I'm going to be tracking data within my program. We talked about the data that we would track in our chapter on software engineering, where one of the steps was to create a data dictionary. That was a list of at least 25 of the pieces of information that I wanted to track. I also remember in our chapter on databases, for each piece of information, like dog age or dog weight, I decided what I wanted to know about it. Do I want to know, what its name is, the type of data that we'll store, like numbers or strings of characters. I also wanted to know its size. Is it 5 in length or 45 in length? So there were some things that I wanted to know about it. On programs, we also track data, and we call them variables. And so one of the things that I want to do is, from my pseudocode, I can try to decide the variables that this program is going to need to keep track of. And several ways that I can do that. If I'm going to ask the user for something, it should probably be stored in a variable. If I'm going to do calculations on it, it should also be stored in a variable. And ultimately, if I'm going to display it to the user, there's a very good chance that it needs to be stored in a variable. So here is an example of our pseudocode to calculate a restaurant bill. And let's just see if we can identify the variables that I might need in order to write this program. Probably going to have some kind of a bill amount, and then something to track the tax and the tip rate. If I'm going to calculate the tax and the tip, then I'm going to need a variable to store those values in so that I can add them to the bill amount and end up with a final total bill. So these are an example of some of the variables that this particular program might be using. So let's talk about variables for just a minute. There is a very specific convention that I can use, or rules that I have to follow when I am giving my variables a name. And the first rule is that the name can only contain letters and underscores and numbers. The name of a variable, there are certain things that it cannot contain. Another one of the rules about variable names is that it has to begin with a letter. A variable name can contain numbers, but the very first character of a name has to be a letter. You want to use descriptive variable names. So var1, var2, var3, while valid variable names are not very descriptive, and so 270 lines of code later, I have no idea what var2 is. And so you want to use descriptive variable names. And in order to use descriptive variable names, sometimes the variable is going to require more than one word. And so one of the characters that I cannot have in a variable name is a space, which means that if I want to use multiple words to name a variable, it can't be first space name. Space is not an acceptable character in a variable name, so I would have to mash those two words together. There's a couple of ways that I can do that. One is using an underscore between the individual words in a variable name, and another one is the camel case, and that means capitalizing the first letter of each of the words. Now, either one of them is acceptable. I have a tendency to use camel case for one reason only, not because it's an industry standard or because it's easier, only because I can consistently find the enter key, and I cannot consistently find the underscore on my keyboard. And so I can type faster and more accurately with the shift key than I can with the underscore. So I use camel case when I am naming my variables. The last rule is that you cannot use reserved words as your variable name. And Python has a variety of reserved words. Python 2 has 31 keywords. We can't use any of these keywords as our variable name. Now, it can be a part of a variable name. Say, for instance, that the first word is and. I can say name and address. That would be an acceptable variable name. I can use the keywords as a part of the reserved words, but I can't use it as the entire variable name. The next thing that I need to know about a variable is the type of data that it's going to store. And in Python, there are 4 different options that are available to me. There are 2 different whole numbers, int and long, and the difference between the two is the size of the number that it can contain. If I want a floating point number or a decimal number, Python has something called a float. It also has a Boolean data type that is yes, no, true, false. In our database chapter, I'm pretty sure that one of our variables in our database had something to do with the dog being neutered, or was the dog fixed, or did they have their shots. And that was a true, false, yes, no question. And then finally, Python also has a string variable that contains up to 255 characters, and they can be alpha or numeric or symbols. We're going to find out in Python that integers can be represented in any of 4 bases. It can be in a decimal. So if I just have a regular number that is not leading 0, Python will treat it as decimal. If I start a number with a 0b, as in Bravo, Python will treat it as a binary number. If I start a number with just a leading 0, Python will treat it as if it was octal or base 8. And then finally, if I start it with a 0x, Python will treat it as if it was a hexadecimal number. These are 4 different types of whole number or integer variables. We're also going to find out that every programming language also has a variety of math operators. Some of these you may be familiar with. Some of these you're probably not familiar with. We're going to experiment with different one of these math operators when we start our programming. Every programming lot also has relational operators, greater than, less than, greater than or equal to. Again, you're probably familiar with some of these, and some of these you're not familiar with. We're going to experiment with these as we write our programs. Programming language also has logic operators, and, or, and not. We have experienced logic operators in our chapter on numbering systems and digital logic circuits, and so all programming languages also allow me to do logical comparisons between, let's say, for instance, variables or literals. The last thing that we want to talk about is the different types of program flow. Top-down is sequential. Step 1, Step 2, Step 3, Step 4. All of the logic, or most of the pseudocode that you've written so far, is called sequential or top-down because you started at the top and you move down. Another type of program flow is invocation. That is where I call or I invoke somebody else's code that I did not write. I'm just going to invoke it or call it in order to use it in my program. The next one is selection, and a selection allows me to choose whether or not I want to execute logic. And there are several different structures that allow me to look at a group of logic and decide whether or not I want to execute it. And the last kind of program flow is called repetition. And this is where I can repeat the same logic over and over and over again until some condition is met. So here's an example of invocation where I invoke asking user for the bill amount is some source code that I can invoke printing to the screen. I don't have to tell the computer how to print it to the screen. I just have to invoke a method that will print to the screen. Here's an example of selection that says, if something is true, then do something. This is an example of repetition, is where I'm asking for the bill amount, calculating it, and then repeating the whole entire thing.